Let us take a look at wholes of rational functions. We're going to explain what wholes are in a rational function, and then we're going to find the whole of several rational functions. So typically, in a rational function, a whole exists at any value where the numerator and the denominator can be equal to 0. So it's usually found at that value of x that makes the numerator and the denominator equal to 0. So you're looking at a situation where the value of x creates this, I'll call it a dilemma, where you have 0 over 0. This is your whole. So whatever value of x makes this possible in your rational function, you have a whole at that value of x. So how do we find the whole of a rational function? We want to factor the numerator and the denominator, and then we want to identify the common factors in the numerator and denominator, and for those common factors we're going to find the 0 of the binomial or the function represented in the common factors. Let's put that to practice. So we want to find the whole of y equal to x squared plus 3x minus 4 over x minus 1. So we factor the numerator and denominator. So we have x squared plus 3x minus 4 over x minus 1. So let's factor the numerator. To factor this, we see that we have minus 4, so the product is minus 4x squared and the sum is plus 3, so we have x plus 4 x minus 1 divided by x minus 1. So normally if you're just trying to solve a function, you would cross this out. So these are your common factors in your numerator and denominator. So what we're going to do now is we're going to find the 0 of that common factor. So x minus 1 equal to 0. We add 1 to both sides. X equal to 1. So what this is telling us is that at the point where x equal to 1, we have a whole of the rational function. Let's try another example. X squared plus 8x plus 15 over x plus 5. So let's look at finding the whole. So to find the whole, we want to factor it first. So x squared plus 8x plus 15 over x plus 5. Let's factor. We have 15, so we need 3 and 5. So we have x plus 3 multiplied by x plus 5 divided by x plus 5. So we can see the common factor in the numerator and denominator is x plus 5. So our whole will be at the 0 of x plus 5. So to do that, we have x plus 5 equal to 0. We subtract 5 from both sides. So x equal to negative 5. So this right here is our whole. So at the function, on the graph, when you have x minus 5, you should see a big circle, which means that that point cannot be valid because it's a whole. So now we have this function, this rational function, x squared minus 7x plus 12 over x squared minus 4x plus 3. So we're going to factor the numerator and the denominator and see if we can come up with common factors. So x squared minus 7x plus 12 over x squared minus 4x plus 3 is equal to, so let's see, we have 12 and we need 7, so that's 4 and 3. So we have x minus 4, x minus 3 divided by, so in this case we have x minus 1, x minus 3, x minus 1, x minus 3. So we can see the common factor is x minus 3. So we're going to find the 0 of that expression or of that binomial. So x minus 3 equal to 0. We add 3 to both sides. So x equal to 3. So this is going to be x equal to 3 is going to be the whole of this rational function.